These are the solutions to the questions at the end of lesson 8.3. Now, number 1, we have unpolarized light meeting a polarizing material. It's always the 1/2 rule, 50%. Number 2, horizontally polarized light meets a polarizer with the axis at 45 degrees. So theta is 45 degrees. If it is initially polarized, we have to use Malice's law. So the intensity will be the initial intensity times cos squared 45, which is 1/2 of the initial intensity, and that is C. Now, number 3, after the first polarizer, it is vertical. Then the middle one is also vertical. So that means it's still vertical. And then the last polarizer is horizontal. So if it's like this, and the last polarizer is horizontal, that means we get 0. So that is A. Now, number 4, we start with unpolarized light, and we have a vertical polarizer. So that means it's the 1/2 rule. It is vertically polarized. It is down to 1/2 the intensity. So A, we simply have intensity is I0 over 2, and that is 1.10 over 2 is 0.55 watts per square meter. And then B, we have our vertically polarized light meeting a polarizer at 75 degrees. So that is Malice's law. So I2 equals I1 cos squared 75, which is 0.55 times cos squared 75 is 0.06699, gives us 0.037 watts per square meter. Now, number 5, it is polarized light to begin with, so we use Malice's law, and that gives us I is I0 cos squared theta. Now, I is 0.764 is 0.883 cos squared theta. So cos squared theta is 0.764 over 0.883, which is 0.8652. So cos theta is the square root of that, 0.930, and that gives us theta equals 21.5 degrees. Now, number 6, we have initially polarized light, intensity I0. Then we have a polarizer at an angle that we'll call theta, and the intensity that comes out of that is 0.94 I0. So immediately we know that I1 equals I0 cos squared theta, and that equals 0.94. So cos theta equals 0.9695. We get theta is 14 degrees. So now we have light polarized at an angle of 14 degrees from the vertical. Now it has to reach another polarizer, and we want 0 coming through. So that means the second polarizer must be polarized at right angles to that. And so right angles to this would be that. So this has to be the second polarizer. So if that's 90 and that's 14, this angle, we'll call it theta dash plus 14 has to add up to 90, because we know that that straight line is 180. 90 minus 14 is 76 degrees from the vertical. Now, number 7, we have I naught is 1260 watts per square metre. So, we have I naught. We have a polarizer, and this is 15 degrees. There we have, sorry, it doesn't look like 15, but that is 15 degrees. And we have a intensity here, and that is in fact I naught over 2 because it was initially unpolarized. The second polarizer has an angle of 55 from the vertical, and that means that the angle that it is, since this is 15, that means the angle between the light and the polarizer is 55 minus 15, which is 40 degrees. So after that we have intensity I2, and that will be I1 cos squared 40. Then finally our last polarizer is at 100 degrees from the vertical. That means the light coming to hit it, which is at 55. Again, we have a change in angle of 45 degrees. So let's write down I1 is I0 over 2. I2 equals I1 cos squared 40. And I3 equals I2 cos squared 45. Now, if we put all this together, we get I3 equals I naught over 2 times cos squared 40 times cos squared 45. Putting those in, we have a half times 1260, the incident I0, times 0.587 times 0.5, and that gives us 185 watts per square metre is our final intensity.